the mounting and dismounting of SKF bearings. In all industries, the efficiency and reliability of plant and equipment is dependent on the rolling element, the bearing. It's the heart of all rotating machinery. To ensure a long and trouble-free life, each SKF rolling bearing is a product of the latest technological development and manufactured to the highest precision and quality standards. It's essential that during replacement of bearings, they should be kept as clean as possible and that the correct handling techniques are used. Like the human heart, the service life of the bearing and the reliability of the plant will be compromised if any of these essential factors are ignored when replacing bearings. This SKF training film is about the lubrication of rolling bearings. Overcoming friction has challenged man ever since he invented the wheel. Friction occurs between contacting surfaces that are in relative motion. If the loads and relative movement increases sufficiently, without lubrication the surfaces will fuse together and seize up. The main purpose of lubrication is to provide a separating film to prevent this happening. For almost a century, SKF have been involved in the reduction of friction and wear by the development and manufacture of a range of rolling bearings and lubricants. Rolling bearings can carry very heavy loads at extremely high speeds, and it's essential to have a film of lubricant between the surfaces. Mineral oil is generally used to create the very thin oil film, which is between 1/10 of a micron and up to 1 micron. Very smooth surfaces and clean conditions are required to prevent the film being penetrated and wear started. To achieve an adequate oil film thickness within the bearing, a number of variables must be considered. The most important is the viscosity of the oil, which influences the film thickness. This is specified as centistoke, or millimetres square per second. As viscosity changes with temperature, this is usually quoted at a reference temperature of 40 degrees centigrade. Viscosities used for bearing lubrication are ranging from 2 centistoke, which is very fluid like water, up to 500 centistoke, which is comparable to syrup. The operating speed has an important effect on the lubrication film thickness. As the speed increases, a condition known as hydrodynamic lubrication develops, which significantly increases the oil film thickness. The effect is similar to aquaplaning. At slower speeds, higher viscosity oils are required to maintain an adequate oil film. In very slow and heavily loaded applications, additives to improve lubrication are required. Temperature within the bearing must be considered. The oil viscosity will reduce with increase in temperature, with a corresponding reduction in oil film. Oils with a high viscosity index limit the effect of temperature changes within the bearing. The operating load has to be considered, as this has a direct effect on the contact of raceways and all rolling elements. Grease is a combination of approximately 85% mineral oil and 15% soap or thickener. The three main soaps or thickeners are lithium, a good all-round grease with a wide temperature range, calcium, which is recommended for installations exposed to water but has a 60 degrees centigrade maximum temperature, and sodium, which has good sealing properties but should not be used in wet applications. All the soaps function in the same way. They retain the oil in a similar manner to a sponge retaining water. The oil is allowed to bleed out as the bearing requires it. Greases are measured by their stiffness or consistency. This, like the oil viscosity, can change with temperature. For bearing, use the normal range of the grease consistency, between 1 and 3, with 3 being the stiffest. Grease is by far the most popular method for bearing lubrication. It's easy to apply and retain within the bearing housing and can also function as a seal to protect the bearing. The bearing should be filled with grease and the free space in the housing up to 50%. This is to allow room for the excess grease to be ejected from the bearing during startup. In slow speed conditions where there's no overheating, a complete fill is desirable. Oil lubrication is a very effective way to lubricate bearings but can present difficulties with sealing. There are several methods which are used, the static oil bath being the most common. The oil level in this instance should be halfway up the lowest rolling element. In most gearbox applications, the bearings are lubricated by oil splash. On critical machinery, such as very large gearboxes or the drying sections of paper-making machines, heat and contamination can be a problem. In such applications, a recirculatory system is used. Oil is fed by pump to the bearings, then allowed to drain back to a sump, where it can be cooled and filtered before reuse. Always use the right lubrication and the right amount for the application. Too much grease can cause overheating. Always keep the workplace clean. With replacement bearings, it's essential to make sure that the bearing is completely full and the housing partially full of the correct grade of clean grease. Make sure the grease, like the bearing, is kept protected at all times. In applications where the operating conditions are hot and where the environment is harsh, it may be necessary to re-grease the bearings. In these cases, provision must be made for the excess grease to escape from the housing. Re-greasing should be done whilst the equipment is still rotating. In some applications, continuous lubrication is preferred. This can be achieved by a centralised system or by the use of an automatic lubricator. Ensure that the lubrication fitting is clean, that the right type of lubricant is used, and that the correct quantity of lubricant supply is set. Sealed and shielded bearings are greased for life and should not be interfered with. The mounting of any bearing is not complete without applying the correct lubricant and ensuring the effectiveness of the sealing. Remember, effective bearing performance is dependent on cleanliness, careful handling, the right bearing, the correct lubrication, and good mounting and dismounting methods. Only then the race for better bearing performance can be won.